slides, which are a little boring, but just gives you an idea of how it develops. But the point of this slide is to tell you that if you see a lesion, it does not necessarily mean anything. We use the term called pathognomonic, meaning that if you see this, then this must be the disease. In amphibians, that generally does not exist. There is not a case where you can look at something and say, oh, that amphibian has this. You either have to do testing, or in most cases, pathology or necropsy after the animal has died. So when we go through and look at the histopathology, what's happening is when we look at the surface of the tongue would be right here. And these would be all the mucus glands that are inside the tongue. So these glands have ducts that come to the surface, and they use fluid, this combination of water and proteins that are secreted by the cells. These cells right here that line the inside of these ducts take the mucus to the tongue becomes sticky. When we have the low vitamin A levels, we have a condition called squamous metaplasia that develops. And squamous metaplasia is where the cells that are normally lining and producing the mucus actually become like the surface of your skin. They no longer can produce the mucus. If we were to look at a couple different slides, or a slide here that shows both conditions, we can see normal and abnormal. And this is a process called a keratin pearl that's basically just like the surface of your skin on the inside of a duct. So this is a change that happens in response to low vitamin A levels. It's just something that happens with the body because we don't have enough vitamin A. But one thing I want you to think about is, this is just on the tongue. What would happen with the reproductive tract or the intestinal tract or the insides of the lungs or the trachea? All the other organs are going to get affected as well. So many other conditions could come from low vitamin A levels. And I think this is a little bit important. This, again, you can go on to Wikipedia and really understand this well. What's interesting about vitamin A is that vitamin A, the pathway vitamin A in vertebrates at least, we know that in humans we have what are called provitamin A carotenoids, and those would be all of the different additives in the Repashy media and the Dendrocare, all of the, Sean, what's your product? Just to give you a little push here. Your whisperer powder or whatever. But a lot of the additives are carotenoids or vitamin A precursors. Inside the body, they are converted to retinol, and retinol is the base of vitamin A inside the body. This particular compound has toxicity. If you give too much of it, it can be very dangerous, just as much as too little. This one can be even more dangerous, retinoic acid. But what happens is the pathway inside the body is you have carotenoids converted to retinol, then converted to retinal, which is goes in the eye. This is where all the vitamin A is in the eye, and it can be converted back and go to retinoic acid. I'm going to tell you why this is important in just a second. It'll become a little bit more clear. The retinoic acid is a one-way pathway. The retinoic acid is the actual part of vitamin A that's free in the bloodstream and does a lot of work inside the body. So what can happen is that if you, and again, just to reiterate what I have here, chemical basis of vision for retinal, and then retinol is a lot of cell metabolism. Well, what's interesting about retinoic acid is that it does another thing I think that's very interesting when it comes to amphibians. And who studies a lot of genetics? Anybody here geneticists? Do you recognize what these things are? RXR, RAR, RXR, and RARE. You've heard of these? Some of these are kind of new, and again, I'm not a geneticist, but I've read about these recently, and what's interesting is that these are all factors of, or aspects of DNA where retinoic acid binds to activate certain genes. And particularly, one thing we see, and this kind of feeds into the spindly leg talk, is that vitamin A is extraordinarily important during differentiation of the embryo. So what vitamin A does is it turns on some of the cells that make the limb start to differentiate. It also is very important in a interaction of different genes. Sometimes we'll have two genes that actually work together, and so retinoic acid is required to activate two genes to work at the same time. And what's interesting is this Retinoid X receptor right here, it's believed that there is another type of vitamin A that was previously unknown that may be synthesized in the body. I want to go back for just a second because the important thing about the precursors to vitamin A right here is that what we don't know in amphibians is how many amphibians use this and can convert to retinol, and how many must take in retinol? This is one thing we don't understand, and it's probably that there are different species by species or genera by genera differences, where some animals can take in provitamin A carotenoids, convert it to retinol, and then this process goes through, and some may have to intake retinol as a dietary supplement. We just don't know which. But there's some evidence that maybe not everything can utilize provitamin A carotenoids. We just don't know. There's a lot that's unknown right now. So it's important to understand that I know a lot of us are doing this and we can see results in coloration, but there may be cases where animals could still become deficient in vitamin A and you're doing everything right, and it may just be the way that animal is programmed. So again, it gets very confusing, but it's very probable that vitamin A is at the base of a lot of health problems with captive amphibians. So again, the things that the vitamin A is doing here, the retinoic acid, is gene activation, modulation, amplification, and influential in gamete production and embryo differentiation. All of these things are important in breeding frogs in captivity. So again, talking about spindly legs, there's been a lot of hypotheses out there. There's a lot of research going on looking in water quality, a lot of different factors, but it would make sense, knowing what we know about vitamin A, that there could be something from the vitamin A of the female going to the egg, and I think that's where retinol comes into play. A possibility that all of the vitamin A that the larva or the tadpole has could come from the female, and that maybe it cannot utilize dietary vitamin A or carotenoids until it metamorphoses. So if many of you who have bred a lot of dart frogs, particularly Atelopus, you know that spindly leg can pop up from time to time, and some people I talk to that are big breeders tell me, I breed my frogs, they do great, and they get about 5 to 6 months into breeding, and then toward the end, I start seeing spindly leg pop up. I give the frogs a rest, they get fed well, I start breeding them again, spindly leg has gone away, and this was with known specific females. So there is a possibility that the animals are becoming vitamin A deficient, total body deficient. So again, this is something to look at, and just keep in mind that vitamin A may be playing a very large role in health of the animals in captivity, because if we're not doing a good job at feeding our food items well and doing the gut loading or doing in cases where it's needed, some of the powder supplements, that might be a source of health problems or lack of successful breeding. And again, just this is a couple Atelopus. I'm not sure if these are Glyphus or Lamosis, probably in Panama. And this is just an example of spindly leg. Most of you have seen it, so I don't need to necessarily show a photo. But it shows up in a lot of different species. It's not just dart frogs. It can be in different toad species. It can be in some of the tree frogs as well. All right, so that was a quick run through. I know it was very fast. I'm going to go through these fairly quickly just to give you some exposure to some of the other processes that happen, and we'll wrap it up. How many of you have heard of lipid keratopathy? Okay, so where it's most common is probably the big tree frogs, the big cricket eaters. Specifically, I've seen it mostly in White's tree frogs. We also saw it in a lot in the, not a lot, but a little bit in the Gastrotheca. And this is an example of it. So if you were to see this in your frog, the first thing anybody's going to think about is, oh, it looks like an eye infection, I need to treat it, I need to put medication on it. Well, in this case, this is actually fatty deposits in the cornea. And the theory is, or what we think is happening, is that the frogs are fed a high fatty diet, or a cricket particularly, that is fed a non-balanced diet or a high fat diet. The body is not used to that much fat, but it decides to store it, and it just happens to get into the cornea. And so this is a situation that is, relatively speaking, a non-reversible situation, non-treatable. If the animal has only one eye affected, as in this one, it can do perfectly well, still eat and do fine, it's just not going to look normal. There have been some very small experiments with Lipitor and other types of cholesterol binding drugs for this, but nothing that I've ever heard was published or amounted to anything. So generally prevention is best, and most of the things we're going to talk about is all diseases that are preventable, not diseases that we treat, but actually we prevent. So again, the primary goal is to slow the progression of the disorder, evaluate and adjust the diet. If you see that in the diet of animals, think about how you're feeding your crickets, and then evaluate other individuals. It's usually a single animal disease, but if you see it in multiple animals, it likely goes back to nutrition. All right, so we'll talk a little bit about some non-infectious diseases and wrap up. Trauma, very, very common. Many of you have probably experienced this, where you get a nose rub or you get a rub over the eyelid. I've even seen some tinctorius that got infections where the bones, the skull started eroding away. And believe it or not, you can treat them and it'll grow back. It's really unusual how these animals can regenerate, but usually transport is the big issue. And we'll get lesions like this, again, Gastrotheca again. It's sad that we're looking at Gastrotheca cornuta for examples of all these diseases, but it happens to everything. But you can see this is an example of a nose rub, but for those of you who have seen these before, you'll recognize that this is actually a healing wound. And the way you tell that is that little bit of white around the edge here. This is new skin that's starting to form to cover that up, and this is actually a healthy bed of tissue, which is probably bone in this case, where the skin is going to repopulate. So this is an animal that had already received treatment, and I might, under certain circumstances, not be treating this animal once we get to this point. But for those of you who have seen this type of lesion or type of erosion, usually it's something you have to get on it very quickly. And most successfully, we usually do topical antibiotics right on the wound. And the best things I've used today are silver sulfadiazine or SSD, burn cream used in humans, or a mixture of that plus Baytril, which is in an ear medicine for dogs. It's actually a water-based ear medicine that contains Baytril and SSD, and just put a drop straight on the lesion. And in absence of that, any ophthalmic ointment or drop that does not contain cortisone, they work very well. I think I have some examples of those here in a minute. I don't think Rob Melancon's not here, is he? These are his frogs from a long time ago. We had some issues with eye opacities, and this is actually a case where a cornea, basically it was eaten through the cornea and the lens prolapsed out of the eye here. But what I wanted to illustrate, and I know it's a really brutal and bad thing, these frogs are getting infections just on their eyes, which was really weird. We never did figure out why. But what's interesting is this cornea, and I know this is a little bit of a blurry photo, this cornea is fully healed. And what's interesting is we think about a mammal, and the mammal can have a corneal lesion, corneal abrasion, and we can treat it and actually make that cornea go back to clear in many cases. In an amphibian, that will not happen. The amphibians form scar tissue that causes that cornea to become opaque, and this is as good as that eye is ever going to look. It will never be clearer than this. And this was an animal that was submitted to a pathologist, an exotic animal pathologist, and they said there's no signs of inflammation there, this is just scar tissue. So sometimes you can have lesions that create scar tissue such that the animal may still not be able to function normally. And for a dart frog that can't see, it can't eat. And so we really don't have too much choice on how to treat this, but just an example of if things go too far, we may not be able to reverse this. I think I have a closer up picture of that eye. Again, what's happened here is the cornea basically melted and the lens prolapsed out of the eye. And again, this was an animal that was right before we euthanized. This other eye here is also deflated, so the same thing had happened here. And again, it was just a bad bacterial infection. So just looking at some examples, this is a little bit older slide I have, but topical ophthalmics and ophthalmic solutions. I like the ointments because they maintain longer contact time. These things work great. Put it right on the wound. Yes, you can get by with Neosporin. Neosporin works fine too, but I tend to like these types of pharmaceutical grade products. They tend to do a really good job. All right, just a few things, few odds and ends. Tumors. Frogs get tumors too. Some of you may have seen those. This is a Metamorphosis species from Southeast Asia. This was actually in Southeast Asia, and this was a tumor on the back of the leg of this frog. I believe it was successfully removed by the veterinarian who I was consulting with. Turned out to be a carcinoma. I'm not sure what the final outcome was on that particular animal, but we can do surgery to remove it. This was a white-lipped tree frog from Australia in the pet trade. These lesions developed, and we did surgery to remove those. And this was an example of removing the mass. Afterwards, this is the actual Baytril otic that I mentioned earlier, just that it's a white liquid, and it does a really good job at preventing bacterial and fungal infections topically. But it turns out that this was mycobacterium infection. So the mycobacterium was causing a growth like a tumor, and actually after we healed this lesion, we had new lesions pop up all over this frog. We had to euthanize. Mycobacterium is not a very good thing to have in a frog population. Generally, if you have positive animals or animals that you suspect are positive, the best thing is quarantine or euthanasia of the animals that are affected. And then this is a rare thing too. This is another one of the smaller species of Metamorphosis, and this is actually a nematode that's underneath the skin. This was a wild-caught imported animal, and we don't get to see that too often. This is more common for those of you who keep snakes. You see this in snakes and lizards a lot, but it does happen also in amphibians, and I've seen this more in toads probably than any other group, true toads as opposed to Metamorphosis. Edema syndrome, I bring this up because this is one of those things that it's still, we don't really have a clue what's going on with this. We think kidney disease is a possibility, but I'll just show you some kind of fancy pictures. This is Oedipus that had fluid underneath the skin. Commonly, the area that's affected are lymphatics. This is an example of a metamorphic frog here. I don't know the species. These are photos from Alan Pessier. And this is all the lymphatic areas of this animal that are basically dilated with fluid. And you might, those of you who kept aquatic frogs, you might be more familiar with this in like the dwarf African frogs and Oedipus, but we also occasionally see it in dendrobatids. And unfortunately, there is not a cause for bloating syndrome. That's why we call it a syndrome. It is multiple different possible etiologies that can be different from animal to animal. It is rarely an issue with a single amphibian group where you have, let's say, a whole tank that gets affected, but it's more commonly just one individual animal. So if we lose it, the best thing to do is do pathology to find out what happened to that animal. Here are some of the causes. Again, septicemia, meaning bacterial infection in the bloodstream, heart failure, liver disease, kidney disease, viral diseases, and just osmotic imbalances from the environment. And again, treatment, it's again usually single animal disease. I don't treat these. I tell the owner, we're not going to be able to find out what happened to your frog or why this happened. We would have to submit it for pathology, but we try to then review husbandry and see could it be a husbandry cause or not. Colloidal prolapse, some of you may have dealt with this. I have some theories on this, particularly in tree frogs where it seems to be more common. I see it most commonly in young growing tree frogs like Agolignus species, and my theory is it's calcium deficiency. I don't know that for sure, and I know there's some parasite issues and there are probably foreign bodies, but I think a lot of these that happen in young growing tree frogs are probably low calcium levels because the muscle tone is not good enough to hold the intestinal cloaca and the intestinal tract, reproductive tract in. And this is a case, this was another Agnomia hyloraborum before the last one that died a few years ago at Atlanta Botanical Garden that developed a prolapse. In this case, this was a mature animal that was imported, so it would have had enough calcium in its body not to be hypocalcemia, but likely here a improper food item, possibly a foreign object got into the cloaca and it pushed, probably in this case, urinary bladder, cloaca, and maybe some intestine out. We were able to repair it, fortunately, and get it back to normal. These are what are called Pursestring Sutures to hold the cloaca together. We do this commonly in birds and reptiles with just 2 sutures. In frogs, usually it takes 3 or 4, but unfortunately it reoccurred on this animal and it died. So what would have had to happen here is probably more of an internal surgery to try to tack down the intestinal tract, but it was a little beyond the desires of the people holding this frog. I think it was Zoo Atlanta. They felt that the animal had been through enough, and so we ended up euthanizing and then saved the animal for morphometric study. And now I think I'm going to finish on this, parasites, because I know this always comes up. And we're going to talk specifically about the most common one we see, which is Raddius. Raddius is in dark frogs. It's in almost, in my opinion, probably almost every frog. I think there's some exceptions. Those would be some of our little tiny arboreal frogs, but most of the frogs that come in contact with the ground have Raddius. And Raddius is a nematode that is commonly called lungworms. So as the name implies, the parasites actually live in the lung of the frog. And the way the life cycle works is that the adult worm lives here in the lung, and it sheds eggs. The female worm sheds eggs that go up the trachea, then the frog swallows it. As those eggs pass through the digestive tract, they basically larvate, which means they hatch. So we see the adult worm passing the eggs out, and then they are swallowed, and then they go down into the stomach and digestive tract. The eggs hatch, and then free-living larvae come out into the environment. So basically you have these little larvae that are very tiny, they're microscopic, you can't see them, so I get a lot of calls about small planaria and other types of oligochaetes that are in the environment of your tanks that are actually eating organic debris. You cannot see the little lungworms on the side of the glass, so the ones you see are actually beneficial worms in most cases. But these go into the environment, and unfortunately, they can live in the environment for a very long time. They're free living. And the way they reinfect the frog is they go back up to the frog and burrow through the skin and migrate to the lungs. So you can imagine when that happens, you penetrate, make a microscopic hole in the skin of the frog, you make a microscopic hole through other tissues, probably get into the bloodstream or go back into the lungs and take bacteria with you. So what I always ask the groups that I talk to about this is what mitigates this in the wild. Let's just say this is what we call a commensal organism. Let's assume that every frog has this naturally, and those frogs in the wild are living fine. They're not dying of parasites. What are the reasons this would be a bigger problem in captivity than it would be in the wild?
Closed environment.
Yes.
Smaller environment.
Smaller environment, and what is the consequence of the smaller environment? Right, higher concentrations. The ability to get reinfected is a lot higher. Let's assume that we can't do anything about that smaller environment. What can we do to try to reduce the concentration?
Ice pods.
Ice pods, possibly, it might work. That's certainly a very valid point. What would be something, if you can't have ice pods, what would be something simpler? What happens in the wild that helps to reduce the concentration of things? Yeah, rain. You get rainwater and you get flushing. So that's one of the things that we do and this is just some gross pictures here. This is a marine toad. So this was a necropsy course. The throat pouch here, breastplate, heart, and the lungs right here real frothy. These were animals that were kept in small 1 foot by 2 foot tubs, full-grown marine toads for an experiment in another country. And unfortunately, they got reinfected over and over. They also had skin lesions, which we knew were probably from the migrating Raddius. But you can barely see some little squiggles here, and I think I have a close-up right here. Those are some of the worms coming out of this frothy pneumonia lung. But what we do with this environment is we just rain on it. You can flow through, so if you have a flow-through system and you rain periodically and you pick up fecal material, you can reduce the amount of reinfected organisms. So Raddius is a disease of management. It is not a disease of treatment. And I've seen cases, I've seen zoos where they will take animals and isolate them and they do fecal tests and they find Raddius and they treat and treat and treat. And I've seen animals treated for 6 and 8 months. They're still positive. And the reason I think they're positive is those parasites are supposed to be there. I don't know what reason, what they're serving, but they're there. They're a commensal organism, but at high levels they can kill. And so it is something that management here can make a big difference on keeping Raddius levels low, and probably with a lot of other parasites that frogs have, for instance, their intestinal tract, it makes a big difference. So again, we really want to think about most of the diseases in captive amphibians as consequences in the environment. They're rarely ever observed causing death in the native environment. And then this controversial statement that I probably shouldn't mention to this group is something that we talk about a lot in conservation. And again, the reason we do is that there are a lot of conservation efforts of all types of animals, not just amphibians, that sometimes maybe they're well-intentioned, but they don't have the positive outcome, or maybe it's more for publicity. But the thing you keep in mind is just because you keep an animal in a box or you put it in a cage, you're not necessarily doing conservation. And I think what that comes to is it's not criticizing, it's just coming to what is the definition of conservation. I think that's what you have to figure out first. Once you decide what that is, then you can grade yourself. But just because we put an animal in a box, it's not conservation. But I'm going to also say in the same sentence that keeping animals in a box for a hobby and personal enjoyment, there's nothing wrong with that. I have absolutely no trouble with it. I keep frogs. I have no trouble with that at all. So I'm definitely not on either side of this debate, which goes back and forth between zoos and the hobby. But it is something I think is a good thing to think about. Just because you're putting something in a box is nothing you're doing against conservation. But I think what we have to do, and with amphibians particularly, is we have to figure out what conservation really is. And I think that, unfortunately, has not necessarily been defined very well. I think we're learning still. So that's all I have. Interestingly, those of you who know Caretophoras, I took this picture a long time ago, but this is the pedal loring. That when this genus, any of this genus sees another frog, immediately the foot goes up in the air and they start wiggling their toes because they are so hardwired to eat other frogs, they lure frogs in. I have not seen Hemifractus do this much, but Hemifractus acts more like a chameleon, and they cue in on frogs very well. But this group here is just very interesting. They are frog specialists, and if they see another frog, they do everything they can to attract it close, and they lunge at it. Well, thanks everybody. I appreciate it. Again, I think